Hello everyone, here are videos for civil engineering. Welcome to the channel Amazing Civil Engineering Studies. Here we have different videos on all topic of civil engineering. Please subscribe and press bell icon, like and share as many as possible. In this video, we will learn about grouting, its types, and procedure with their advantages and disadvantages. What is grouting? Grouting is the process of placing a material into cavities in concrete or masonry structure for the purpose of increasing the load-bearing capacity of a structure, restoring the monolithic nature of a structural member, filling voids around precast connection steel base plates, providing fire stops, stopping leakages, placing adhesives and soil stabilization. They are used in repairing concrete cracks, filling seams and gaps in tiles, gaps for sealing and waterproofing, and for soil stabilization. It is also used to give additional strength to the foundations of load-bearing structures. The grading is basically a process of injecting a pumpable material into a structure to change its physical properties. There are different types of grouting: cement grouting, chemical grouting, and bituminous grading, depending on the material used. Resins are also sometimes used as grout materials. The grading is commonly used to fill cracks and voids in soil or rock. Also, it is used to strengthen the soil and make it impermeable. Cracks are used in a variety of applications such as water repair, stopping in submerged structures such as canals, tunnels, etc., filling seams between tiles and stabilizing the soil. Here we have given information about the type of grouts used in the repair of cracks. Grout is a composite material generally consisting of water, cement, and sand. It is typically used for filling voids under machines or other structural elements, sealing joints and openings in surfaces and reinforcing existing structures. It is also used for giving extra strength to the foundations of load-bearing structures. Grouts are used in a variety of applications such as repair of cracks, water stopping in submerged structures such as canals, tunnels, etc. Fill seams between tiles, and for stabilizing soil. Here we have briefed about types of grouts used in the repair of cracks. Grout have many advantages. Easy handling. Pre-mixed to ensure high-quality mortar. One component product, just add water and mix. Shrinkage compensated. No segregation or bleeding. Can be poured or pumped free-flowing grout. Fills any voids, cavities, gaps and recesses, e.g. machine and base plates, doweling reinforcing bars, fixing posts, etc. Bedding joints in precast concrete sections. Excellent bonding and strength. Excellent flow properties. Adjustable consistency. Fast strength development. Highly effective bearing area. Good adhesion to concrete. Advantages of grouting include: this can be done on almost any ground condition. It does not induce vibration and can be controlled to avoid structural damage. Improvement in ground structures can be measured. Very useful for limited space and low headroom applications. Used for slab jacking that lifts or levels the deformed foundation. It can be installed adjacent to existing walls. Can be used to control seepage, groundwater flow, and hazardous waste materials process and its types. Different types of grouting. Based on material used. Cement grouting. Chemical grouting. Bentonite grouting. Resin growing. Bituminous grouting. Sometimes resins are also used as grout material. Grouting is generally used to fill the cracks and voids in soil or rock. Also, it is used to strengthen soil and making it impervious. Cementitious grout. Cement grouting is also known as slurry grouting or hydraulic cement grouting. Cementitious grout is used to seal wide cracks, particularly in gravity dams, canal linings, foundations and thick concrete walls, and also used for enhancing extra strength to machine foundations, base plate, or anchor bolts for machines or equipment and others. It is divided into the following class depending upon the size of particles. Ordinary Portland cement grout. Microfine cement grout. Ultrafine cement grout. Ordinary Portland cement grout. This is the most common type of grout used for repair of concrete cracks. Wider cracks can fill up using OPC grout as they have the particulate size of 15 microns. Microfine cement grout. It is finely ground slag, fine fly ash, or Portland cement that are all mixed with water for allowing penetration into the fine cracks. Silica flume or any other fine pozzolana can be used with microfine. The particulate size of microfine cement grout ranges from 6 to 10 microns. Ultrafine cement grout. They are used for sealing very fine to hairline cracks. They have particles of size 3 to 5 micron. Chemical grout. Chemical grouts consist of polymers such as acrylic, polyurethane, sodium silicate, epoxy, or any other suitable polymer. Chemical grouts are an emulsion of water and liquid resin. Chemical grouting requires injection of specially formulated chemical grouts into finer cracks that cannot be possible by cement grouts. They can be applied in moist environments and can fill very fine cracks. Acrylic grouts possess flexural and tensile properties. It allows less penetration of water. Acrylic grouts are used in sealing cracks in exterior walls. Epoxy grout is an excellent material for grouting applications that require high strength. Epoxy grouts are non-shrinkable, viscous, and are very effective in sealing cracks. They have good adhesion with almost all building materials and have good chemical resistance. Polyester-based grout. Polyester grout is used for anchoring to impart strength to foundations that must be achieved in limited available space. It can also be made to have special characteristics such as fast setting, free flow, no shrink and others by an addition of different additives as per the end user requirement. Non-shrink grout. Non-shrink grout is useful for sealing of cracks where shrinkage cracking is anticipated. Such grouts are specially formulated and have a special blend of cement, aggregates, and other additives to compensate for possible shrinkage, flowability and setting time considerations. Non-shrink grouts are also used for connecting precast concrete sections. G1 grouting. This type of grout is generally for steel structures, towers, ships, small pumps, and all non-vibrating machinery, but the precise application of the grout type to any location will be according to the relevant drawing. The grout shall be a non-shrinking, free-flow cement-less grout with a minimum compressive strength at least equal to the foundation concrete, but not less than 30 N/mm2 7 days and 40 N/mm2 28 days. Will be less than. G2 grouting. This type of grout will be used, in general, in prefabricated concrete structures, compressors, and other heavy equipment subject to vibration and for column-bearing plates of heavy structures. The minimum compressive strength of grout will be 50 Nm2 in 7 days and 60 Nm2 in 28 days. The flexible strength of grout should exceed 9 Nm2 in 28 days. Types of grouting method. Permeation grouting, Compaction grouting, Hydrofracture grouting, Jet-grouting, Rock grouting, Compensation grouting, Deep mixing method, DMM. Grout is injected into the soil at low pressure and fills the voids without significantly changing the soil's structure and volume. Variety of binders are used with this technique, the choice of which is dictated mainly by the permeability of the soil. When the coefficient of permeability is greater than 10 to 2 cm SEC, water cement mixes are used, and for permeability as low as 10 to 5 cm SEC, the more expensive resin-based grouts are used. Soils with values lower than 10 to 6 cm SEC are normally not groutable by permeation. Permeation grouting. It involves the filling of cracks, joints, or other small defects in non-cohesive soils, sand, or other porous media. It is a ground treatment method in which grout is injected into aporous medium without disturbing its original structure. It is usually referred to the process of filling the pores and joints in a soil and rock deposit to change its geotechnical properties. Soft ground settlements, sinkhole problems, and rock fractures are often the types of problems that can be sustained when buildings and structures are built on sandy soils or gravels. Permeation grouting helps strengthen sands and gravels, and repairs structural formations. The process produces a solidified mass to support increased load and fill voids in the soil. Permeation grouting is used for the agglomeration and solidification of unstable gravels, sands, and other non-cohesive soils at depths as great as 60 m. Compaction grouting. Compaction grouting involves the injection of a low-slump, mortar grout to densify loose, granular soils and stabilize subsurface voids or sinkholes. Compaction grouting can solve soil density problems. In this technique, a stiff mortar-like mixture is pumped into the soil. Rather than flowing through the soil, it forms an expanding bulb, displacing the soil while forcing out air and water. The resulting denser soil has a higher load-bearing capacity, thus stopping or preventing settlement. It can also be used to lift settled structures. Compaction grouting utilization. It is used to improve bearing capacity of soils for new construction or adding load to existing structures. It is also used for densifying soils and lifting settled structures, stabilizing underground formations for pipes, improve bearing capacity of soils, and manage sites with sinkhole activity. Advantages of compaction grouting. Here are some advantages of compaction grouting. Rapid installation. No spoil generation. Can be accomplished in restricted access situations. Structural foundation connections not required. Low mobility grout rheology allows for precisely controlled placement. To increase bearing capacity. To arrest or reduce foundation settlements. Mitigation of liquefaction potential. Sinkhole remediation. Stabilization of karstic formations. Compaction grouting limitations. Not suitable for soils with deficient permeability, i.e. clays. Zone where limited overburden above the grout zone results in heaving. Usually, a minimum of 5 FET of overburden is required. Compensation grouting or hydrofracture grouting. It is agro-grouting technique in which a low viscosity cement grout is injected under high pressure. The grout will split open the ground using hydrofracturing, and it creates lenses that would penetrate void spaces or fractures. Soils are also displaced using this process. Fracture grouting is commonly used for structures releveling and on stabilizing overlying structures during tunneling. It is also known as compensation grouting. This method involves the intentionally fracturing of soil or solid rock by grout under pressure. This results to a compact soil and stiffening of rocks. Use this ground improvement practice where other procedures, especially permeation grouting, is not applicable on actual. Once the procedure of hydrofracture pressure is exceeded, fractures open in the soil or rock and instantly broaden by the incursion of the grout. The process results in releveling and stabilize overlying structures. Fracture initiation. Soil types differs on the failure mechanism of a fracture. Grouting for cohesive soil and cohesionless soil, non-cohesive soil, are two different agenda in which the cohesion greatly increases the probability of fracturing. We use a type of this technique to lens grout radially as shown in the detail below to mitigate expansive clays to a certain degree. We create radial lenses close to the surface and grout in stages every 6 inches. The amount of stages is usually 5 to 6. This technique creates a barrier to stop soil saturation, and Portland cement reduces the effect of the mineral smectite that causes the swelling of the clay. Procedures of hydraulic fracturing. The procedure for fracture grouting is a well stimulation system in which hydraulically pressurized liquid composed of water, sand, and chemical mixture is used to fracture rocks. Pre-split holes are provided for artificial cracks. Grout is forced down the holes or other holes drilled in the same area. Casing are injected to fracture sections to prepared, inserted and grouted. A pressurized fluid carrier of prop pant is injected into the opening casing and spread to the fractures. The casing used for injection remains open after fracturing. Jet grouting. What is jet grouting? Jet grouting is a process of creating soil concrete columns or jet grouted columns in place with astabilizing grout mix delivered under high pressure and flow through nozzles at the end of a monitor inserted in a borehole. The soil concrete column is created by rotating and lifting the monitor at a pre-calculated slow, smooth, constant speed. Cutting the soil with water and or air while feeding an engineered grout slurry at high pressures through the base of the monitor to achieve thorough mixing and a consistent geometry and quality soil-crete columns. The common uses for jet grouting are to underpin foundation, to seal the bottom of planned excavation and to provide support on the excavation. Jet grouting process. Jet grouting system can stabilize foundations, provide barriers, and gives excavation support. Jet grouting ground improvements finds application for the following. Horizontal barriers. Groundwater control. Tunneling. Support excavation. Underpinning. Jet grouting procedure. Initially, the area where the soil has to be treated is chosen and a hole is drilled to the required depth. The depth depends upon how deep the weak subsoil exists. The hole drilled may be small, of approximately 10 to 20 centimeters. Drilling can be done by rotating drilling system under high pressure to the desired depth. The next step is to place the equipment over the drill hole to conduct the injection process. The equipment consists of a jet grouting string of almost 10 cm diameter. At the end of this string, it possesses a nozzle in order to have an injection at a higher velocity. The nozzle is small, of diameter ranging from 1 mm to 10 mm. Figures showing jet grouting procedure: A. Drilling, B. and C. Jet column formation. Now at the start, the string is raised and rotated slowly to seal the whole column surface with soil and the fluid system that has to be injected. Now the main jetting starts. As it progresses, the fluid is injected, through a rotary motion, and the string is raised. Now between the process, a part of mud within the pit created and the fluid mix rises to the top, which is called as spoil. This gives an indication that the bottom is fully sealed with the grout and soil mix. The raising of the string is done in between the process at a distance of 40 to 100 mm depending upon the depth of treatment. For each raising, a rotation is performed. There are certain systems in which raising is a continuous process along with the rotation of the string. The speed of rotation of the equipment is kept constant irrespective of the method chosen, which will help in giving us a properly refined grouting column. Jet grouting methods. Now, based on what system of fluid is employed for the grouting process, the method of jet grouting varies. Mainly the available techniques are grouped in three main jet grouting systems, namely single, double, triple fluid systems, which are classified based on the number of the fluids injected into the subsoil. The fluids are grout, i.e. water and cement for single fluid, air and grout for double fluid, water, air, and grout for triple fluid. Based on the number of fluids employed, the jet grouting strings are made up of different pipe types as shown in Fig. Single fluid jet grouting system. In the case of a single fluid system, the W grout is injected into the ground through one or more nozzles. Here the soil remolding and subsequent cementation are done by the same fluid. The functions of removing the excess spoil and the binding action are all conducted by a single fluid. This system has a limitation of losing a high amount of kinetic energy. This is because of high friction existing that a single fluid finds it difficult to manage alone. Double fluid jet grouting system. In double fluid system of jet grouting, the soil disaggregation and cementation are carried out by a single fluid, i.e. the water cement grout, but the difference is that the jet of grout is sent to an area of air that enhances the effectiveness of reducing the energy loss. For this, a more suitable air jet is provided through a coaxial annual nozzle place around the grouting nozzle. Here the excess soil is removed by the action of the airlift. Triple fluid jet grouting system. Here the soil remolding and cementation are clearly separated. The soil loosening is done by a high-velocity water jet and air. The water jet provided with the help of coaxial air jet, supplied by an annular nozzle similar to the one used for the double system. The water cement grout is then taken from a separate nozzle that is placed on the lower part of the monitor or nozzle. The purpose of grout is in cementing the soil previously remolded by the water jet. Due to this reason, the grout is delivered at a lower velocity. Applications of jet grouting. Jet grouting finds is a method of ground improvement and finds applications in the following. 1. For construction of horizontal barriers. 2. Control of groundwater. Jet columns can act as horizontal barriers to control the groundwater around dams or areas of contaminated ground. This also decreases the soil permeability. 3. Underpinning. Jet grouting can be employed as a method to stabilize foundation systems, mainly shallow ones. The procedure involves drilling through the nearby foundation and making a stable bed underneath the footing for better load distribution. 4. Tunneling. Jet grouting stabilizes the local area under tunnel construction so that heavy equipment required for tunneling can be used without destabilizing the nearby areas. Advantages of jet grouting. Jet grouting provides with the following advantages when implemented, which are the root causes behind its success. Large cemented material column creation without causing huge ground disturbances, subsoil. Columns form continuous elements forming in different shapes, thus improving the mechanical properties and decreasing porosity. Improvement in construction process, thus emerging out with a better design philosophy. Its attractive nature in terms of confined space working and under difficult site conditions. Compensation grouting. Compensation grouting is an active technique used to counteract relaxation of the ground caused by tunnel excavations. Compensation or fracture grouting is the injection of a cement slurry grout into the soil, creating and filling fractures that then lift the overlying soil and structures. How it works. Compensation grouting is a method in which precise and typically small quantities of grout are injected between the tunnel roof and the structures exposed to danger with low grout pressure and flow rate. It can be carried out via either using sub-vertical or sub-horizontal drilling. Process. A pipe with rubber sleeves covering ports is inserted into a pre-drilled hole beneath a structure and grout injected under pressure at strategic locations through the ports. Once the hydrofracture pressure of the soil is exceeded, fractures open in the soil and are immediately expanded by the influx of grout. This results in the controlled heave of the overlying soils and structures. Grouting procedure for repair of cracks in concrete structures. Procedure of grouting for repair of concrete cracks in structures are: holes are drilled in structure along cracks and in and around hollow spots. If there are several cracks, holes can be drilled in a staggered manner at 500 to 750 mm spacing in both directions, covering adequately the area proposed to be grouted. Hole spacing can be altered as per site conditions. GI pieces, 12 to 20 mm diameter x 200 mm, with one end threaded or PVC nozzles are fixed in the holes with rich cement mortar. All the cracks and annular space around GI pipes are sealed with rich cement mortar. All the cracks are cut open to a V-shaped groove, cleaned and sealed with rich cement mortar. All the grout holes should be sluiced with water using the same equipment a day before grouting as per following sequence, so as to saturate the masonry. All holes are first plugged with proper wooden plugs or locked in the case of PVC nozzles. The bottommost plug and the two adjacent plugs are removed and water injected in the bottommost hole under pressure. When the clear water comes out through the adjacent holes, the injection of water is stopped and the plugs in the bottommost hole and the one immediately above are restored. The process of grouting of concrete cracks is repeated with other holes till all the holes are covered. On the day of grouting, all the plugs are removed to drain out excess water and restored before commencing grouting. The same sequence as described above is adopted for injecting the cement grout also. The grout is kept fully stirred/agitated under pressure throughout the grouting. The grouting is carried out till refusal and/or till grout starts flowing from the adjacent hole. A proper record of the quantity of grout injected into every hole should be maintained. After grouting, curing should be done for 4 days. Telltales are provided for checking the effectiveness of grouting. Only such quantities of material for preparing grout should be used, as can be used within 15 minutes of its mixing. Grouting equipment must be cleaned thoroughly after use. See image for grouting procedure for concrete repair. Precautions during grouting of cracks in concrete. During the grouting operation in track or close to it, speed restrictions of stop dead and proceed at 10 km/h shall be imposed at the site of work, and same should be continued for a period of 24 hours. The restriction may then be relaxed to non-stop 30 km/h to be continued for a period of another 2 to 3 days. However, speed restrictions indicated above are only guidelines, and appropriate speed restriction at each individual site should be considered. Immediately after grouting work, all the grouting equipment including the slurry and mixing drums, pipes, nozzles, etc. should be thoroughly washed so that set cement does not damage the equipment. After the work has been completed, it should be inspected thoroughly and should be kept under observation for a period of 6 months to 12 months for its behavior after grouting. In case arch masonry of bridges is grouted to strengthen the structure, some load tests may be carried out in selected cases to satisfy that grouting has helped to reduce the deflection of crown and spread at the springing to within permissible limits. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.